Hey, 250B students, good to see you. I promised you a couple little fill-in things since I'm going out of town from Wednesday night that I didn't quite get through that I thought I would put on a video for you. So I hope this is helpful to you. I'm going to keep it real short so you don't have to spend a lot of time with this, but this might help you with some of the homework as well that you're going to be doing for Friday, and I won't be around in my office on Friday, so hopefully this gives you a little bit of an idea. First, I wanted to show you an example of using elementary row operations to help us find the determinant of a matrix. So remember that in class we talked about how permuting two rows inserts a minus sign into the determinant of the matrix. And if we multiply a row through by a constant, the determinant gets multiplied by that constant. And if we add a multiple of one row to another, then there's no effect on the determinant at all. So let's say we took this matrix right here, and we wanted to find its determinant. Of course, you could just use the ERO method here, or just cofactor expansion. You don't really need to work that hard because it's only a 3 by 3. But I still want to just do it using elementary row operations so you can see how the process would work on maybe a bigger matrix. Okay? So the first thing that we would do is try to use elementary row operations to bring this matrix into row echelon form. So I would start by taking A and I would permute the first two rows. Okay, so if I do that, I'm going to get the first row is -1, 2, and 6. The second row is 2, 1, and 3. And the third row is still 4, 1, and 12. Okay, now I'm going to take multiples of the first row and add them to the lower rows. So I'm going to take A1, 2 of 2. Okay, so I have -1, 2, and 6. And then I'm going to get a 0 of 5 and 15. Okay, and then I'm also going to do A1, 3 of 4. So I'm going to get 0, 9, and 36 if I do that. Okay? Next, I'm going to multiply the second row by 1/5. Okay, so that's a different ERO. So I'm going to leave the first row the same. I'm going to multiply the second row by 1/5 so that it becomes 0, 1, and 3. And why not? Let's multiply the third row by 1/9. And that'll become 0, 1, and 4. Okay? You don't really have to do that, but it's okay. And then finally, I'm going to do A2, 3 of -1. Okay, so -1, 2, and 6, and then 0, 1, and 3, and then 0, 0, and 1 is what I end up with. Okay? Not quite row echelon form, but this is actually upper triangular. So you remember that the determinant of an upper triangular matrix is just the product of the diagonal entries. So in this case, -1, 1, and 1. So the product of those is -1. So this matrix that we ended up with has a determinant of -1. So I just want to show you now, we can go backwards through these steps to get the determinant of the original matrix. So this last ERO that we did has no effect on the determinant, right? So the determinant of the matrix right here is also -1. Okay? Now the big step is really from here to here. When I went forward and I applied my EROs, I was multiplying by 1/5 and 1/9. But that means that when I go backwards to find the determinant of this matrix, I need to multiply by 5 and 9. Right? I'm taking the reciprocals of those factors. So 5 times 9 is actually 45. So this matrix has a determinant of -45. Okay? I hope that's clear. This is the key step. When we're going backwards, when we're tracing backwards through this multiplication step, we actually have to divide by whatever we had multiplied by. So the 1/5 becomes a 5, and the 1/9 becomes a 9, which multiplies to -45. Okay, this matrix has the bigger determinant. It becomes smaller when I go from left to right. So when I go from right to left, it has to become bigger. Now we pretty much have it. If we go backwards one more step, this is just the A operation twice, and that has no effect on the determinant, so it's still -45. And then here, the very first step, we did a permutation, and hopefully you remember that to find the determinant of that, we just permute two rows, and that picks up a minus sign. Okay? So the final answer for the determinant of this matrix would just be 45. Okay? Hopefully that's clear. If you're having any trouble with any of those problems, feel free to contact me through email, and I'll try and give you a hand in the next couple of days.